Good afternoon. My name is Joerg Baumeister. I'm very happy and honored to present at the Australian Institute of Architects. And before, I want to talk about pioneering aquatic urban development and about our SeaProjects. I would like to introduce myself very briefly. So I'm a trained architect and urban designer in Europe most of the time. I was running my own office for 10 years. Simultaneously, I taught at various universities and did my PhD in parallel. And then after completing a large project and finishing my PhD in 2007, I took a gap year. And this gap year is still ongoing. So I was spending 3 years in Ethiopia, where I restructured universities and programs, established a chair for urban design, planned new cities, focusing on rapid urban development and poverty. Subsequently, I was part of a team that built up a new university in the Sultanate of Oman. I conducted their research projects on traditional oasis towns as self-sustainable systems. So that's where I learned how to deal with self-sustainability in an urban context. And then I served as director of the Australian Urban Design Research Centre in Perth, UWA, where I consulted the government on ecological cities and urban sea level rise adaptation. So now I have to clarify, so in the end it's not a gap year. My whole career changed now since 2007, and it is still very, very exciting to be more on the scientific part, but at the same time, the more we are working on our projects, the more we are also getting back into relationship to industry to apply these projects. And as I said already, as I promised already, you will see some of the projects in a few minutes. So that's the SeaCities Labs team. I'm the director and founder. We are situated at Griffith University's Gold Coast campus as a world first highly interdisciplinary initiative. We are building on synergies between established disciplines, including architecture and industrial design, urban and marine planning, marine science, system dynamics, and marine and civil engineering. This is an invitation to visit our newly launched floating online exhibition, which provides an overview of our project. So today I can show you just 5 projects. There are much more. And additionally, on our website features also more videos showcasing implementation of our work, while books, and these are all our books here, present the scientific background in depth. So you are welcome to explore more of SeaCities Labs publications in our web library, including the research on urban wetland oasis, then floating mangrove platforms, adaptive planning tools for urban seascapes, of course, food production technologies at sea, and another example is living islands in atoll environments. There are much more topics. The SeaCities Lab capitalizes on the ocean's opportunities to create positive change in the world. Today's theme 1 will promote sea level rise not only as a threat, but also as an opportunity. For environmental protection, theme 2 will present floating artificial reefs and survey structures as effective solutions. And for food security, theme 3 will showcase aquaculture as a more lucrative alternative to agriculture. And I was mentioning also here the collaborators in this project, the main collaborators, so that I won't forget to mention them. So theme 1, cities plus 1 meter, and this will be presented now very soon. I did that together with Despina Linaraki. In theme 2, the Sea Manta project was done with Nikki Findlay, Sea Surveyor with Atiria Morrison, and the food security Sea Fisher with Martin Siermal, and last but not least, the Sea Oasis by Joanna Joerg. So now we are starting with theme 1, which is about urban scenarios for sea level rise. I have to start with 2 slides introducing the problem, just to get everyone updated in terms of the question, how far do we know nowadays about sea level rise out of a scientific perspective. So sea level rise will happen, but no one can predict how much. For example, there's a significant difference in the greenhouse gas emissions predictions over the next 25 years, and greenhouse gas is the main driver of greenhouse gas emissions. To limit global temperature rise to 2 degrees, emissions need to decrease dramatically in the coming years. That's shown here as a green curve, the targeted limitations of 2 degrees Celsius, and this is coming from United Nations, IPCC, and other partners. However, government projections show that emissions are expected to increase. So this is now the red curve, and this is an outcome of a scientific survey asking individual governments about their targeted or estimated greenhouse gas emissions in the next years. And you see on the horizontal x-axis what they predict. So there will be the peak in 2030, and then it will slow down a little bit, but not really as predicted as through the 2-degree target. Additionally, despite of improving accuracy of climate models, there's a growing recognition that the role of Antarctic ice dynamics, so this is what is happening below the ice in Antarctica, which is not visible to satellites, has been underestimated. Therefore, we need to prepare for the possibility that sea level rise could reach up to 35 centimeters in 25 years or more. So that's the dotted line coming from the 2050 up vertically, and then matching the 0.35 meters, so 35 centimeters. And this is just an estimation, as I said, which is including partially Antarctic ice dynamics. It can be also more or less. So this sounds dramatically, and it is somehow dramatically changing our cities, but we don't have to panic. Here you can see, for example, Hamburg's New Haven City development, and I was participating there too, that is able to deal with 8-meter storm floods. So we are talking about perhaps 1 meter or a little bit more in 2100, and this is already executed for 8 meters here. Not sea level rise, but storm floods, but still. So they were able to deal with that. But there will be profound changes to our coastal environments also, already with 35 centimeters in coastal cities. And this will impact infrastructure, buildings, parks, industry, and communities. and it will cost trillions of dollars per year. To minimize costs, coastal communities are currently preparing their cities much like a ship would be prepared for an approaching storm. Future damage will be minimized using strategies such as protection. So on a ship, you are closing the hatches, for example. Accommodation, you are changing the course of the ship to avoid the center of the storm. And in an emergency, retreat, where you abandon the ship and you're boarding the lifeboat. Following these strategies, communities are doing the same. They are protecting cities with hard engineering structures like seawalls. They are accommodated buildings and public spaces to withstand flooding, or they abandon certain areas to be flooded. Sorry, I have to drink something. I have to flood my mouth a little bit. How can we shift our perspective beyond just focusing on expensive risk management? How can we transform coastal cities to handle sea level rise in ways that create opportunities? To achieve this, we are proposing two measures. First, we are suggesting to implement also, or to consider also an additional strategy that advances cities towards the sea. So this is our fourth strategy, and that's the reason why we are thinking a lot about floating structures, because they can become also in the future part of cities. So all our four examples I will show you later are all using this advanced strategy, because this is not very well known currently. And then the second measure is the implementation of a guideline that incorporates all strategies, including this advanced strategy. So this Cities Plus 1 Meter guideline, which is co-authored by Despina Linaraki, promotes the flexible application of strategies for different urban areas and combines them for various scenarios. So you can see here we are starting with a quite deep analysis, and then we are coming up with a second chapter, which is about concepts and tactics. And this is that's the chapter where we are mixing different concepts with different texts, and we are coming up with different urban scenarios. And then in the third chapter, we have a feedback loop where we ask stakeholders, and then at the end we are suggesting final scenarios. I will show you some slides in 1 second, which is showcasing that a little bit more. So the whole goal of this guideline is to find the optimal mix of urban, green, and blue development tailored for each city. So this is now the additional test run, which exemplifies the application of the guideline. So here we were selecting one area that's somewhere at Gold Coast with a river which has sea level rise issues and will become more. And so this is our test area. I think it was 300 by 300 meters, the square, the test area. And then we were doing different analysis in terms of looking at the different elevations to be sure or to get an understanding which one will be flooded soon and which one later. So here the deeper gray, the earlier it will be flooded. And then we were also coming out of a kind of a building analysis and infrastructure analysis together with the elevation analysis to a risk map. Sorry, I forgot also the natural environment. So also um, 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 trees were also considered because they are also somehow they have to interfere with sea level rise. So, and in the risk map, there's the darker red, the more risk. So it's more on the left-hand side, closer to the water. And then there was something happening, which is in the bottom right one, where we were subdividing the site into 9 individual pieces. So we were using this trick to be sure that we can implement in different areas of this test site different strategies. And that's exactly what we were doing. So we were combining the different subdivisions, and then we were looking what is happening if we are applying for each of the subdivisions different scenarios. So we had, I don't know how many hundreds of results out of this combination exercise. And then we were coming up with the different scenarios. So that just to exemplify that we can have a kind of a specific order and arrangement and selection if we are going, for example, with minimal change. That means there's in terms of short term costs are limited, we are building seawalls and so on. And then the next one is maximal yield. So we are using that as an opportunity, but more out of a perspective of developers. Maximal nature, that's the same opportunity, that's also opportunity, but now more out of a natural environment perspective. And then the fourth scenario was about maximal water. So this is the question, how can we use water to create opportunities for the site in the future? Here you can see the different illustrations, very abstract, how this could work. So if you would apply the minimal change scenario, for example, you can see here there's a seawall, which is becoming also a park. But in the end, the small little canal, which is on the site currently, will stay there. All the buildings are also staying there. On scenario B, that's now that developers and the current citizens are agreeing on changing some of the uses of the area, and then there will be much more yield coming out of that. The third one is there will be maximum nature. That means, of course, there will be buildings also, but the buildings will be integrated in the nature, and the nature will be then close to the water, more wetlands, and then it will change. And then the last scenario is the maximum water scenario, where you can see how much you can just build and develop in a way which is highly attractive if you also consider the advanced strategy um, and you are creating lots of water sites. And then I would just want to suggest you another book, which is here called also SeaCities, but this time Aquatic Urbanism. This is a book we were somehow publishing last year, and this is now focusing on this new advanced strategy, and we were coming up with the typology, what can happen on the water if we are thinking about aquatic urbanism, and some of the typologies will be exemplified now in the upcoming examples. Because now we finalized the theme number 1, and we are now, or I'm showing you now 4 examples, 2 about environmental protection and 2 about food security. So the first one is called the Sea Manta, and the co-author was Nikki Findlay. All 4 projects I'm presenting are starting with a research problem. This is not to be special negative or whatever, it's just to identify very, very correctly and clear the problem we are facing, because this is creating for us a kind of a research framework with the research question, how can we solve the problems? And this is creating then the factors that are helping us to come up with solutions. So this is now the Sea Manta. And this map shows the predictions by the World Economic Forum that half of coral reefs and associated tourism are at risk by 2035, which is alarming, half of the coral reefs. Yeah. So therefore, our client wanted to create an artificial coral reef with an integrated marine ecosystem. So you can't just create an artificial coral reef. You need also the whole ecological surrounding that can be enjoyed by divers, both above and below the water surface. So the idea was, okay, below there's a floating reef, but then above the area can be used also differently. And then if it would be about divers or dive tourism, and then the dive tourism can then watch again the whole reef, which is creating somehow synergies and double benefits. So this is now a cross-section through this floating reef called Sea Manta. So, and one of the main ideas was that we were using electroaccumulation, where low voltage current is passed through the structure to grow a limestone-like substance. So from the dissolved minerals in the water. So we are creating out of the water the material we need to settle this reef. And this is not our invention. This has been done, and the electroaccumulation, or the low voltage current of the electroaccumulation, is helping to increase the pace of this limestone settlement. So therefore, the corals and their related systems, they are natured. So the related ecosystems in this aquatic nursery to settle. So then there's also dive attraction, and the whole structure is also somehow fixed, but just with a single point mooring. And sometimes the question comes up, why single point mooring? It's just because of the forces. So if the whole structure is directing automatically towards current, wind, waves, and then there's not so much forces on the structure. So environmental factors such as water current, wind flow, and sunlight drive the evolution of the structure's form. This is something you can see on the top here. And we were starting to first develop the shape for the water current. Then we were looking at the wind flow and how this is now creating the shape. And if I say it's creating the shape, it's about the scientific experiments and the simulations, and they were done physically and digitally, of course. So we had our models, and then we were doing hydrodynamic analysis, and then also wind analysis, and then we were building models. We were putting them into the flume tank and in the wind canal, and out of that, this model has been improved and improved. So what I can say is that the final design is purely scientifically driven at the one hand side, and at the other hand side, it is directly linked to a specific site with specific environmental factors. So this was for the Arabian/Iranian Gulf. Here, the site was east of Qatar, and there are specific environmental conditions where waves are not very high, and then there's not very often a stronger wind, which is called Jamal. So that's 1 or 2 times a year, and the rest it's very calm. So if the conditions would be different, the shape would be also completely different. It's the same with the sunlight. We need for the corals sunlight. And the first measurement was that we were cutting into this shape, which has been developed out of the water current and wind flow simulations. We were cutting something in the middle out, because it was too wide, the structure. And then we were also just extending this belly-like structure under the water so that the sunlight would get also access there for the corals which are positioned there. So, and this was creating this kind of wing-like shape, and therefore also the name sea manta. This is a simulation of the interior now. So in the middle, there's also a glass-bottom pool, and then there's also the stairs are going up for another dive experience, because you can jump down then through the central pool, and then there are 2 rings below on a 12 and 18 meter depth, which is following some dive certificates. And then you are in this other world, in this underwater world. And this is just to demonstrate that it's a functional structure with a proper also engineered structure, properly engineered structure. And there are functions like the boat mooring, and then, as I said, the glass bottom. There's an exhibition space, breeding aquarium down for the whole ecological environment, then a paddling tool pool, then event spaces, observation decks, and so on. So this is a structure which is about 60 meter long, and this could be built very soonish. So this is now the elevation, and again, the structure, the shape of the structure is not because we like this kind of dynamic forms, and you see very soon also other forms which have been created out of other reasons, out of other factors, but in this time it's really about dynamics of wind and water and sunlight. So that was the first example. And the sea manta, which is a floating outpost for the settlement of heat-resistant corals. And now the next one is the so-called sea surveyor, and we are starting again with a problem. And this case, it's not so much a problem. It's somehow, first of all, very, very cool that the United Nations, finally, all countries agreed that they want to designate 30% of international waters as marine protected areas. International waters are the areas outside of exclusive economic zones. So exclusive economic zones are somehow following the jurisdiction of each specific country. International waters doesn't have any jurisdiction. And it's amazing, especially because the size is almost half of the complete surface of the globe. And these international waters, they can't be controlled, so because no country is responsible for that. But the United Nations were able now to come up with the first legislation regarding marine protected areas. And now the big question is now, how should they be controlled? How can you control these huge areas? So we, and this is a project which has been designed with Arteria Morrison, suggest using autonomous platforms for integrated remote undersea surveillance. So you see one of these devices here floating around. Therefore it's called Sea Surveyor, so it's surveying an area. And the construction is around a modular platform. It measures about 35 by 70 meters in this case, but it's flexible, and it's based on a 7 by 7 meter grid. Again, it features single point mooring, and in this case, the shape is completely different because there's an aluminium cover that serves as a protective enclosure for safeguarding data on top. So now here you can see it, the total annual cost of operating 15 of the sea surveyors, and thanks to the autonomous vehicles we would like to use, there are just 15 requires of the sea surveyors to control 30% of the marine protected areas in international waters. And the cost for that would be a fraction of the UN's $1 billion peacekeeping budget. So hopefully UN will be interested in that, and if somebody has good contacts, please inform us. Yeah? The next project is the project called Sea Fisher. So the background is here that the increase in fish farming is pushing operations offshore, and this results in construction of large and costly steel structures normally. So therefore, we were asking ourselves the research questions, and then we are answering them also already directly afterwards. First, how can greater flexibility be achieved? And the answer is that we are coming up with a modularity which allows greater flexibility in prefabrication. The second research question was, how can material prices be lowered? And there the solution for us was that we are using HDPE, that's high density polyethylene, as a load-bearing material. That's the first time. Normally there are the current coastal fish pens, there are out of also HDPE, but they are very flexible, and we are using the HDPE material different. It has advantages like affordability, recyclability, full recyclability, and then also it's very, very environmental positive, and at the same time they're not big biofouling issues. So the Sea Fisher is a significant project within the CRC blue economy. So CRC, these are very large research clusters in Australia, and the blue economy CRC is one of Australia's most extensive research initiative, and we were leading phase 1, and this has been completed, and we are now also underway with phase 2. And coming back to the initial question about making it less costly. So due to the modular submersible HTPE construction, and we have patented that also, the costs are reduced by 3/4. So hopefully we will be able to come up with first prototypes in 2 or 3 years' time for that. So that's now the last project. It's called SeaOasis. And the research problem at the very beginning is something which is somehow frightening and very, very negative, because if you look at the global hunger index and then you see how many countries are really suffering due to hunger, alarming, seriously or moderate, but there are lots of countries suffering, lots of people worldwide suffering. And so if we are looking how much additional food we would need, and then we can say that the global community needs to increase cropland by 2-fold. So this project, SeaOasis, has been co-developed by Joanna Joerg, and this is now a self-contained, closed-loop floating farm system, like an oasis, designed to empower smallholders in developing countries. And it enables them to cultivate high-value cash crops for international markets, while also producing fuel and food crops for local consumption. So this is a kind of illustration. So there are different ponds, they are combined together. And this is, for example, now a section through the hydroponic pond that comprises a base unit with a rope and buoy system. You can see it perhaps. And these elements serve as the framework for attaching locally built floating plant beds. So everything is geared for low-tech applications, and then also for people maintenance. So in terms of self-helping them, and therefore also the structure is perhaps the cheapest structure, and we are using as elements tractor tubes. So if one is flat, and then people can also repair that. So here, in addition to the hydroponic unit, which is here on the left-hand side, there's also the fish algae unit, which is on the top, the filter unit on the right-hand side, the pump unit in the middle, and all the units they are now connected with water cycles, nutrient cycles, and food and energy crop cycle. And it's not just about the connection, it's also about the different now setups. So you can set up now these pots in different ways, and you can grow different species in it. So we were just mapping here the different configurations which would be possible, and by integrating the multiple crop species in various salt and freshwater configurations, they can be tailored to specific climatic conditions. So there's a business case behind it, and what we can say is that the return of investment for family systems will be after 1.5 to 3 years, and then afterwards that would be then create food and income at the same time. So I think that's it for today. I didn't show you additional projects which are related to energy security, such as floating wind turbines and energy islands. There's a project called SeaWatt. And then I didn't also show you our ideas about future transport, in regards to floating logistic hubs, which is called the Seaport. And then we have also tools to predict future developments on the sea in international waters, which are able to avoid maritime conflicts. Everything is accessible under www.seacities.org. Yeah, so if you have any feedback, just write us. We are also thinking about doing a kind of a weekend course where people then also not only now get the information, but then can apply it with us together to develop their skills also in terms of sea level rise, urban sea level rise adaptation, and using these advanced strategies. So we are happy for feedback, and thank you very much for giving us, or myself, this opportunity to present our projects here. Thank you very much.